And we're back. So
Again.
so I just fixed my green lines here. I wanted to divide my 180 into 6 slices. So I divided it in half first, and then divided those into thirds. So notice there are 6 green slices. So the question is, what is 180 divided by 6? What is the size of one of those slices in degrees? Right? 180 divided by 6 is 30. So that means that this slice is the same as pi over 6. All right, is my 30-degree slice. What if I double that? That would be 30 times 2 is 60. If I double it in terms of radians, pi over 6 times 2 is 2 pi over 6, or pi over 3 when I reduce it. Okay, so this would be 3 pi over 6, which reduces to pi over 2. This would be 4 pi over 6. What's that reduced to? 4 pi over 6 reduces to 2 pi over 3. And this would be 5 pi over 6, which does not reduce.
Are you doing this 6 from the 6 slices?
Yes.
Oh.
Yep. All right. And those are equivalent to 30 degrees, 45 degrees, 60 degrees, etc. Now, what if I wanted a green angle, this green angle down here? What would this location be?
7.
7 pi over 6 slices, right?
Yeah.
Perfect. And that doesn't reduce. What would this green angle down here be?
8 pi over 6.
And what's that reduced to? 4 pi over 3, yep. Helping each other out. Now what would this green slice be? How many green slices is this?
9 pi over.
That's 9 of them.
9 pi over 6.
And what's 9 pi over 6 reduced to? 3 pi over 2. The other way I could have gotten this one is, here's my pi over 2, my quarter slice. So here's 1 quarter. 2 quarters would be 2 pi over 2, which reduces to pi. And then 3 quarters would be 3 pi over 2. And this would be the same as 4 pi over 2, which does reduce to 2 pi.
Why isn't the 6 changing?
Well, it does sometimes. Like here.
No, I mean, like, why is it still 6? Because there's 1 green slices. You know what I'm saying?
Right, yeah. I divided this top half into 6 slices, is where pi over 6 came from.
Isn't that 1 6?
No, the green.
Yeah, 1, 2, 3, 4, 5, 6.
Sammy can do the yellow and green. That's really key in this presentation. Is the difference between the yellow
Yep.
and green.
Very. Sorry.
What's the yellow?
Sorry, my colorblind friends. So if this is pi over 4, here's 2 pi over 4, 3 pi over 4, friend, 4 pi over 4, and 5 pi over 4. And then this would be 6 pi over 4, which reduces, and this would be
What's up with these yellow lines?
7 pi over
I don't
4.
understand these yellow lines.
I'm just distinguishing between my pi over 4 slices and my pi over 6 ones.
Well, why?
And what would this one be? The green,
10.
9, 10 pi over 6, which reduces to 5. No. 5 pi over 3, right? I think, yes. And this last slice of our special angles, 11 pi over 6. So anyways, so here's a representation of a bunch of possible radian angles, all of our significant ones. And so now if I wanted to take those and say evaluate what is sine of pi over 6? So Eventually, I want you to know these well enough that you don't have to always convert them to degrees, but I understand if today you would. So sine of pi over 6 is the same as sine of 30 degrees.
How do you know that? Oh, 6.
And that is 1/2 according to the hand trick. What would cosine of, Dylan friend?
Yeah.
5 pi over 4 be? So, well, actually let's ask this. What is the reference angle of 5 pi over 4? Let's draw a picture. So here's, I guess I'll draw it in yellow for consistency. So here is my 5 pi over 4. So which quadrant is that in? 3. Is cosine positive or negative in the third quadrant? Negative. So this is the same as negative cosine of which angle? What is the reference angle here? Well, this would have been 4 pi over 4, right?
So what would you be pi over 4?
So it's pi over 4, exactly. And pi over 4, cosine of pi over 4, I guess I'll do it down here. Cosine of pi over 4, what is the angle pi over 4 is equivalent to? Right? So that's the same as if I asked what is cosine of negative 45 degrees. So that's negative root 2 over 2. All right, so these radians are really, they measure exactly the same thing degrees do. If you're going to use a calculator at any point, understand that you actually have to set the mode properly in order to do that. So how about some other things radians can do real quick? Check this out. Suppose I've got a unit circle and then, terrible. And then just any other circle. So they have the same center. These are concentric circles. So here, this is radius 1, radius 1. Here's angle theta. This is the arc length here is theta. If this is, right, theta radians, this is theta. And if I continued this arc length we're going to call S. All right, and I believe you've seen a formula for arc length in the past in geometry, and it was related to proportions, and really this is as well. And this length will be my radius. So if I want to calculate the arc length of a non-unit circle, all right, so it's got a different length radius than 1, I can set up this proportion here where I could say that S over theta in radians should equal R over 1. You guys agree? So arc compared to arc should equal radius compared to radius. It's a proportion. And what if I wanted to solve for S? What could I do to both sides? How do I get S by itself? Quick, quick, quick. Multiply by theta. And baseball hat down at the end there. What we end up with is S is equal to R times theta, and that's a formula for arc length. All right, where all I do is multiply my radius by theta, not in degrees. It will fail if you use degrees, but in radians. So let's do a quick example of that. So what if I have a 5 centimeter radius, and what is the arc length of a What should I call it? Let me be sneaky. What if I want a 120 degree central angle? And the vocabulary for central angle, it's just referring to an angle whose vertex is at the center of a circle. So suppose this is what I'm looking for. So I can draw a little picture, I suppose. So I've got a circle, as always. How convenient. I guess I'll draw a circle in white. That is a perfect circle, thank you. So let's see, 120 degrees is like this, right? And I'm looking for this arc length. So the distance it would be if you were to travel along this arc right here. So in order to find that, let's see, we also know that our radius is 5. So my formula is S equals R times theta. So I need theta not in degrees though, but in radians. So that means S is equal to, the radius was 5 times, what's 120 degrees in radians? Pi over 2 would be 9 degrees. Well, let's see, 120 degrees is 2/3 of 180. So it's got to be 2/3 of a pi. Or 2/3 pi radians. So I'd end up with 10 pi over 3 is the arc length in centimeters. And since this is a kind of a wordy problem, it would make sense for me to do that. Get the dimensions. So this would be 10.471.
Why?
Pay attention. So 10.47 centimeters is how you could find the arc. Now similarly, not only can you find arc length, but there's also finding the area of a sector. Do you guys know what a sector is? A sector is the area, all right, is the area of one slice of our circle. Okay? And there's a proportion you may have learned in the past that said that the area of the sector over the area of the whole circle, all right, would equal the, well, I guess we could compare it to arc length. Or sometimes we did it in terms of degrees, over the, what is the arc length around a whole circle equal to? What's the distance around a whole circle? Circumference, or 2 pi. Exactly. Except now what we're going to do is relate this to radians and have an even nicer shortcut. So A is equal to pi r squared. Arc length is r theta, right? And 2 pi. So if I wanted to solve for A, what could I do? Multiply by pi r squared. Multiply by pi r squared. And I get A equals, watch what cancels out. Watch it carefully. There goes the pi's. Wait a minute. Wait a minute. What did I do wrong, guys?
No, I don't know. Wrong, Maggie.
Oh. Guys. The circumference is 2 pi r. I had 2 pi in terms of radians. My apologies.
Silly, Ronnie.
Silly Waddy is right. So these r's would cancel out. I'd be left with a is equal to 1/2 r squared theta.
It's a good movie.
Where theta, gentlemen, is in terms of radians. So this does not work if theta was in terms of degrees. So we'll do one last example. Well, maybe, yeah. Find the area of a sector if, let's say, this is the situation. So here's my circle. Let's say I've got this situation here. What if it's a radius of 3 and this is true? What is the area of this sector? Right there. Well, I could label my facts. I know that r is 3. What is theta equal to in radians? 90 degrees is the same as what in radians? Pi over 2. So that means the area is 1/2 3 squared times pi over 2. So that is 9 pi over 4. And that would be in like centimeters squared or something like that if this was originally in centimeters. So voila! And then you can convert that from there. But alright, I gotta shut this down. Bye, Internet.